So a very good morning to all of you. So today we'll be discussing about this interrupt priority register. That actually this is the bit addressable register. So this bit addressable register can be accessed by bit. So here we can set or reset a particular bit depending on the requirement. So here you can see that PT2, that timer 2 is not available in case of 89C51. But in 8031 series or 8052 series, this timer is available. So in case of 89C51 IC, this particular PT2 bit will be unchanged. Okay, that will be ignored. That will be by default 0. Okay, and rest of the bits, PS is the serial communication. P means priority. Here P means priority, and the second one, second letter, that is S or T1 or X1, that S denotes the serial communication. T1 means timer 1, X1 means external interrupt 1, T0 means timer 0, and X0 means external interrupt 0. Now, let me tell you that this is the default order of priority. That means if everything is set by 1, if every bit PS is 1, just like this, if PS is 1, PT1 is 1, PX1 is 1, PT0 is 1, PX0 is 1. So if every bit is 1, then what happens? Then what will happen? Then by default, as I told that by default this particular bit is the has the highest priority. Okay, then this, then this, then this, and then lastly this. So this is the default priority. Now you can also tell that again this situation may also arise, that PT1 and PX0 both are 1, rest all are 0. Okay, then what does it mean? It means that particular this PT2, sorry, PT1, this bit is set. Okay, that means this priority, I mean the priority of this PT1 is higher than that of the PX0. Okay, and if it is 0 and 1 bit is 1, then obviously this is the highest priority. Okay, understood or not?
Yes, sir.
Understood?
Understood.
Okay. So any questions on particular this priority? Look, one more thing, that whenever we are setting the priority, uh, that is to be noted that multiple interrupts are there. Where multiple interrupts are there, then only this priority must be set. This is mandatory thing. Okay, and this priority is like this. You people have learned in the earlier semester also, that microprocessor, in the microprocessor there is the interrupt interrupt priority things. Okay, so just yesterday, I mean not yesterday, in the previous class, we have discussed about this particular, sorry, particular this register. Okay, so this IE register is not bit addressable, but IP register, that is interrupt priority register, is bit addressable. Okay, and in the earlier class we have put some programs. So have you done it? Anyone? I have given a hint also. Have you done it or not?
No, sir.
Okay, so I'm giving you one more chance. So by this week, please complete this. Okay, so that we can discuss it. Discuss these kind of problems in the class. So unless you people do, you will not learn. Uh, I can solve this problem, but I'll not. Okay, I'll discuss with your solutions. Clear? So do this in the next class. Okay, so we'll just forward that we are just this is the end segment of this 8051, the interfacing part. You can just go through the syllabus also. So here we will be discussing about the external memory, external IO ports, 7 segment display, interfacing with the LCD, interfacing with the keyboard. Okay, that keyboard is nothing but our this keyboard that is connected to desktop or laptop also. This keyboard and LCD. This LCD is nothing but uh, you know that LCD, that how that can be shown, and this LCD can are used in the calculators and other display devices. Okay, and 7 segment display, we will come that there are 7 segments. You have seen it, but whenever I will discuss, then we'll come to know about it more. Okay, and external IO ports, that includes this particular 8255. Okay, to increase the number of input output ports, this 8255 PPI, programmable peripheral interface, that is used. And external memory, we have already learned the interfacing between the 8051 and the particular RAM, ROM. Okay, different sizes ROM, different sized ROM, RAM, and this interfacing was done by using some decoders and some NAND gates. Okay, so this particular memory address decoding, that CPU, I think, is it visible in the blue side slide? Just a minute. I think now it is visible. So,
Yes, sir.
yeah. So memory address decoding, this CPU provides the address of the data desired. You people know that how this can be done, because it was discussed a long way back. Okay. So decoding circuitry locates the selected memory block, and that is decoder. Whenever we are using some decoder, some address lines or select lines will be there. That was denoted by Y0, Y1, Y2, Y3 in such a way. And after this, these methods of decoding the address, the chip select pin of the memory chip must be activated. If you can remember, this CS pin was active low pin. So this active low pin must be activated by using this particular select lines, that is the output of the decoder. Okay, so and data bus of the CPU connected to the data pins of the memory chip, and you will just go through the picture also, that control signals read connected with output enable and write connected with write enable of the memory chip. Okay, so we'll just go back to this particular is a long way back to the interfacing of the RAM and ROM with the 8051 microcontroller. I think we are about to reach, yeah. So here some diagrams or something, they are going wrong. So anyway, whenever we are using some decoder, uh, this is not showing. I think the color has been changed. So this is the decoder, okay, and this was the address lines that is directly connected to the. This is the. So here it will be ROM only. Okay, now you can see that using the decoder, the address line select line is there, and this is the chip select pin that is active low. So if any signal, I mean any low signal comes into this pin, okay, then only this chip will be activated. Okay, just a minute. I think now it is visible, right? Yeah. So now it is visible. So we can just we can see that there are some number of select lines available, okay, and this is connected to chip enable. So this chip enable is nothing but an active low pin. That means if a low signal comes, then this chip will be activated, okay. So by this way we have connected this thing, and this the, and again we will see some RAM. Yeah, here is the RAM. Yeah, so here is the RAM. So we can see that by using some what happened? Pooja, do you want to say something?
No, sir.
Okay. So this was again this particular chip enable. This is the data ROM. So you people have remember this, okay? So this was the Vinod. Please keep your mobile muted, okay? Otherwise noise is coming. Okay, so I'm just going back to this position. Okay, so this was the interfacing with this particular 8255A. We will find something is going wrong here. I can understand that whether. Okay, let us take this one only. So this is the 8255 pin. You can see that there are input output ports for transferring some data, handling some data, and the number is here. You can see that port A is there, okay. You can see this port A, okay, here, and here also, okay. So there are port A, number of port A is 8, okay. So if this pin, this particular 8255 is connected with the microcontroller 8051, then what happens? We are additionally getting some extra pins that is dedicated for the input output purpose. Okay. So here also we will find that port A, port B, and port C, these three ports are available. So obviously these four ports, these three ports, each of 8 bits. Okay, that means eight number of pins are there. Okay. Now again we'll go back. This P port C is there. You can see. So there are also port C, number of pins are 8, and port B here, and here also. So the number of port B is number of pins that is available in the port B, that is also 8. Now here we will see that D0 to D7, these are the pins that is dedicated to transfer the data between the 8051 and the 8255 microcontroller. So here what happens, this 8255 is nothing but, suppose we want to connect a stepper motor, a keyboard, a 7-segment display, an LCD with this particular microcontroller. So microcontroller is having only four 8 bit ports, input output ports, port 0, port 1, port 2, and port 3. So by using these ports, it is not possible to connect a number of devices. Okay, but it can be done by using this particular 8255 PPI, because of having, suppose by this 8255, this is connected to 8051 microcontroller. So by using this particular port will be connected to any of the port of the microcontroller. So by using a single port, okay, single port of, suppose in the 8051 we are using port 0. So port 0 have 8 pins. So by using those port 0, this 8255 is connected. Then how many extra input output pins we are getting? Suppose this port 0 is connected with port 1, port A here. Okay, so I'm writing port 0 of 8051, that is connected to this port 1. Okay, so what happens? So in extra port C and port B, this particular, by engaging one port, this port B and port C, two 8-bit ports are available. Understood? Whatever we have given the example earlier, that if you have two hands and you are holding two people hands, then you'll be having a total of 4 hands. Okay, so like this way this can be increased. So we can also interface multiple 8255s with the microprocessor only, not with the microcontroller. Why? Because microcontroller is the dedicated purpose device. Okay, it can just control one 8255 uh, in a single time. Okay, so this is the so this is the interfacing with the LCD. This LCD interfacing is nothing but this is the very interesting thing. So just a minute. I think this cannot be completed today. So I am just record your attendance. Just a minute. Just record your attendance. So everyone have recorded their attendance.
Yes, sir.
Okay. So you may leave the class now.
Okay, sir. Thank you.
Thank you.